Good morning. Happy St. Patrick's Day. Today, students, we're going to learn another way of approximating square roots. This time we're going to learn to simplify those roots and then approximate. This is a cool method. It has some pros and cons. The pro really is that it's way more accurate than the one that I showed you yesterday where you make that fake fraction thing. It's really accurate to within plus or minus 1/1000th. And you will need this skill later in geometry and algebra 2 and beyond. The cons is it really only works for certain numbers. It doesn't work for every number, and you do need to memorize some values or have them written down somewhere. And these are those values. At least there are more that might be useful, but for our purposes, probably if you knew the square root of 2, 3, 5, 6, and 7 to 3 decimals like this, so take a moment and write those down. You'll need those to do this work. And finally, this number, 8.485, let's keep that in mind. That's going to come up later. So if we have these numbers, and we need to find a number like, I don't know, the square root of 72. Well, I could use yesterday's method by breaking this up into a fraction. It's somewhere between 8 and 9. I'm sorry. No, it's not. It's between, yeah, it is. It's between 8 and 9. So what I want to do is, for this method, though, is to, let's think about ways that we could break this up into multiplication. 72 times 1 is 72. 36 times 2 is 72. So I'm writing different factorizations. 18 times 4 is 72, and let's see, 9 times 8 is 72. So all of these things, all of these different factorizations are equal to 72. But I picked this one because, look, each of these three factorizations has a perfect square in it. 36, 4, and 9 are all perfect squares. I'm looking for a factorization that has a perfect square, but is the largest perfect square. So if you can find a perfect square factorization, then I want the largest perfect square. And now I'm going to write this. I'm going to use this factorization here, 36 times 2. So the square root of 72 is equal to the square root of 36 times 2, because, of course, 36 times 2 is 72. And now I'm going to sort of wave my hands and skip a little bit of math, and maybe you'll understand this later. Maybe I'll make a video, but it turns out that we can take this and we can break it up into two different square roots. Square root of 36 times 2 is the same as the square root of 36 times the square root of 2. You cannot do this with addition or subtraction inside the root sign. You can only do it with multiplication. So, but the cool thing here is I know the square root of 36, that's 6. And then I have times the square root of 2. And so this is a simplified version of the square root of 72. It's going to be equal to 6 times the square root of 2. And we call this simplest radical form because it's radical, bro. All right, so now we know that this is 6 times the square root of 2. And the reason that I had you write down these numbers is because then I can use my pencil or my pen and do the square root of 2, which is 1.414, times 6. And let's see what that equals. 6 times 4 is 24. 6 times 1 plus 2 is 8. 6 times 4 is 24. 6 times 1 plus 2 is 8. Oh my gosh. And there are 3 decimals, so I got 8.484, And the reason I wrote this down earlier is because with my calculator it said 8.45. So we were off by 1/1000th. So it's much simpler. Much more accurate. So for today's work, you should practice this. Figure out a factorization, a multiplication problem that uses a perfect square